The vector quantity has both magnitude and direction. We can represent vectors using directed line segments, as drawn here. So a line between the 2 points A and B with an arrow to show the direction. We can write any vector in different ways. So the vector between A and B can be written as AB with an arrow to show the direction is from A to B. It can be written as a bold A or an underlined A. The direction of the arrow shows us the direction of the vector. We can add two vectors together using the triangle law for vector addition, which is shown below. So to add vector AB and vector BC, we get the vector AC. This can be shown looking at the triangle below. So if we draw the vectors AB and the vector BC, this is the same as the vector AC. We can also write this as A plus B equals C, where vector AB is bold A, BC is bold C, and AC is bold C. The resultant vector is the vector sum of two or more vectors. If PQ is equal to RS, then the line segments PQ and RS are equal in length and are parallel. Vector AB is the same as vector minus BA, as the line segment AB is equal in length, parallel but opposite in direction to BA. Subtracting a vector is equivalent to adding a negative vector. So A minus B is the same as A plus minus B. Adding the vectors PQ and QP gives the zero vector. You can multiply a vector by a scalar. If the number is positive, the new vector has a different length but the same direction. If the number is negative, the new vector has a different length and opposite direction. Any vector parallel to the vector A may be written as lambda A, where lambda is a non-zero scalar. For this question, we're given three vectors and asked to draw diagrams to illustrate the additions of the following. So for part A, we need to draw A plus C. Vector A is a straight horizontal line, and it's important to put the direction arrow on and label this as vector A. Vector C is on slope, and again it's important that we label this as vector C and add its direction arrow. This means that if we draw the resultant line between the two endpoints, we get the vector A plus C. We can do the same for question B. So again, if we draw vector A with its direction and label, and then we add vector B with its direction and label, and then we add vector C with its direction and label. Then we can draw the resultant line between the endpoints, and we can label this as vector A plus B plus C. For this question, the first thing we need to do is draw a parallelogram. We can then add the information that we know to the parallelogram. So we know that side AB is equal to P, which I'm going to underline as I can't write in bold on here. And we're told that vector AD, so this vector, is equal to Q, which again I'm going to underline. This also means that BC must be Q, as it's the same length and parallel to AD, and that DC must equal P, as it's the same direction as AB and they are parallel. We're also told that E is the midpoint of AC. So if we draw a line connecting A and C, E is the middle of that line. So if we use our diagram, part A wants the vector AC. So to get from A to C, we first go from A to B and then from B to C. So we write that as the vector AB plus BC. But we know that AB is P and BC is Q. So we can simply write that as P plus Q. If we look at part B, we want the vector DB, which is the same as DC plus CB, or we can think about that as DC minus the vector BC. So we can write that as DC plus the vector CB, which is the same as DC minus the vector BC, which we know is equal to P minus Q. The last part's the hardest, so we want the vector B to E. So starting at B, we would go B to Q and then C to E. So we write this as B to C plus C to E. But we don't know what the vector C to E is. However, we know that it's half of C to A. So we can write this as B to C plus half of C to A. We don't know what C to A is, but we know what A to C is from part A. So we can write this as B to C minus half of A to C, which is B to C minus half of A to B plus B to C. Which we know using a diagram that B to C is Q. From part A, we know that A to B plus B to C is P plus Q. And we can simplify this to get Q minus half of P minus half of Q, which is just equal to a half of p minus q in a bracket. To show that vectors are parallel, we need to show that one is a scalar multiple of the other. To do this, we can factorise both of our vectors. So we can take a common factor of 2 out of our first vector, and we can take a common factor of 5 out of our second vector. If we put them equal to each other, we get that 2a minus b is equal to 5 2a minus b. So 2a minus b is equal to 5 over 2, 2a minus b. This tells us that our scalar, lambda, is equal to 5 over 2. And we can write our vectors as 10a minus 5b is equal to 5 over 2, 4a minus 2b. Therefore, our vectors are parallel. We can also write vectors as column vectors. For example, vector A is equal to p over q, where p is the change in the x direction and q is the change in the y direction. To multiply a column vector by a scalar, lambda, we multiply both the x and the y component by lambda. To add two column vectors, we add the x components and then we add the y components. We can use unit vectors, which are vectors of length 1, to represent vectors in 2 dimensions. The unit vectors along the x and y axis are denoted I and j, where I is the vector 1, 0 and j is the vector 0, 1. You can write any 2-dimensional vector in the form pi plus qj, where p and q are just constants. You can also write this as a column vector. So pi plus qj is the same as writing p as the x component and q as the y component. So if we look at this first example, we're asked to find 3a minus 5b. So we can substitute in our column vectors to give us 3 and the vector 4, 7 minus 5 times the vector minus 6, 3. When we're multiplying by a scalar, we multiply the vector components both by that scalar. So if we look at the first term, our vector becomes 3 times 4, which is 12, and 3 times 7, which is 21. We do the same with our next vector, so we're going to leave the minus between our two vectors and we're going to times both things by 5. So 5 times minus 6 gives us minus 30, and 5 times 3 gives us 15. And now we can subtract. So when we subtract, we do our x component, take away our second x component. So 12 minus minus 30, and our y component 21, take away our second y component 15. We can simplify this, so 12 minus minus 30 is the same as 12 plus 30, which gives us 42. And then 21 minus 15 gives us 6. We can do the same with this notation. So if we look at question A, we can substitute our vectors A and B. So this becomes 2, 3i minus 6j. And again, I'm going to underline my vectors because I can't write them in bold. Plus b, which is 4i plus 3j. So I can expand my brackets to give me 6i minus 12j plus 4i plus 3j. And just like with algebra, I can now collect like terms. So if I collect my I terms together, I've got 6 plus 4i, which gives me 10i. And then I've got minus 12j plus 3j, which gives me minus 9j. For part B, I'm asked to draw a diagram to represent the vector A, which is equal to 3i minus 6j. So 3i is a vector in the x direction of 3 units. And minus 6j is a vector in the y direction, but downwards as it's negative. So we can then draw the vector A from end to end. If we look at part C, we're asked to write vectors A and B as column vectors. So vector A is equal to 3 minus 6. So the I component is my x component and the j component is my y. And component vector B is equal to 4, 3. I can then use this to find 3b minus a, again by substituting my column vectors in. So this gives me 3 multiplied by the vector 4, 3. Take away the vector 3 minus 6. Again, I can multiply this out by turning both components of my vector by 3. So my first vector becomes 12, 9. And the second vector stays as it is. And then I can subtract, which gives me 12 minus 3 and 9 minus 6. So 12 minus 3 gives me 9. 9 minus 6 is the same as 9 plus 6, which gives me 15. So now try the following questions from the textbook. So from exercise 11A, questions 1, 2 and 4, and exercise 11C, questions 1, 2 and 3. Make sure that you come and see any of the maths teachers if you're having problems with this before the homework is due in.